Hi, we're going to do a quick mini review to get ourselves in the mood for the final. We'll start with number one. We did this at the end of chapter 5. We look at this and it reminds us of our sum formula for cosine, right? The formula cosine, I'm going to use x and y instead of u's and v's. X minus y is equal to cosine x cosine y minus sine x sine y, right? And so what they've given us is they've given us the right side of the equation. And so can you see that what they've given us matches up to the right? And so the left side is what we want to be writing down. What they've given us is the same thing as saying cosine of 75 minus 15, since our x is 75 and our y is 15. Well, cosine of 75 minus 15 is the same thing as cosine of 60, which when we think about the unit circle, we know that equals 1/2. So all of this is the same thing as 1/2. It would have been much simpler if they just would have written 1/2, right? Right. All right, let's look at number 2. I recognize this as a sine sum formula. The formula is sine of x plus y is equal to sine x cosine y plus cosine x sine y, right? And so they've given me this part is the same thing as this part, where what? Our x is 75, right? Our x is 75. And our y, lots of blue going on here, our y is 15. So what we want to do is rewrite it looking like the left side of the equation. So we know it's a sine sum formula, and we know we just said that x is 75 and y is 15. So we're going to rewrite that. 75 plus 15 is 90. And so we'll have sine of 90, which is equal to 1. So all of this right here is the same thing as 1. So it goes without saying that the nice thing about our sum and difference formulas is that although we don't know without a calculator what sine of 75 degrees is or cosine of 15 degrees is, but we can use our sum formula for sine to know that the whole thing is equal to 1. Okay, find the measure of an angle between 0 and 360 degrees that's coterminal with each given angle. So remember what coterminal means? It means this. Any angle, like let's look at this negative 40 degree angle, has an initial side, which all angles on the unit circle have the same initial side. And so its terminal side, the other side of the angle, which let's see, it's negative 40, so it's about here, right? This is my negative 40 degree. So its terminal side is the side of the angle that's not the initial side. And so a coterminal angle would be finding another angle that shares that terminal side. So when we think about it, let's think about a positive angle with the same initial side, but instead of positive angle that goes around this way, that also has the same terminal side. So when we think about that, well, if we went all the way around, it'd be 360, but if we back it up 40, we end up with an angle of 320. So 320 is considered a coterminal angle with negative 40 because they both share the same terminal side. All right. And 320 is in between 0 and 360, so we're good there. There are millions and billions of angles that are coterminal with negative 40, but we're asked to find an angle that's between 0 and 360 degrees. All right, so let's look at 390. Now, 390 itself is not between 0 and 360, but that's okay. We'll find a coterminal angle that is. So when we think about 390, we think we're going to go all the way around 360 and then go whoop, a little bit more. So this angle in red is 390 degrees, and it's pretty clear what my coterminal angle is going to be that lies between 0 and 360. We're just going to look at the angle with that initial side and that terminal side, and we know that that's going to be 30 degrees. So 30 degrees is going to be my coterminal angle with 390. Okay, write each measure in radians, express the answer in terms of pi. All right, so when we're given degrees, to get rid of the degrees, what we do is we multiply by 180, by pi over 180. Why do we do that? Well, when we think about it, we think about where pi is located, right? It's right there. Oops, all right, come back. So that's pi, that's also 180. So 180 degrees is the same thing as pi, which is why we're allowed to multiply 120 by it, because pi over 180, since they're both the same value, is just equal to 1. And we can multiply anything times 1 and not mess with its value. So what we're going to do by multiplying by this, we see that we can simplify. We can say, what, 6 goes into 120 degrees, or you know what, how about 60? That's even better. So 60 goes in 120 degrees 2 times, and 60 goes into 183 times. Note that the degrees, the units cancel each other out, just like in chemistry or in physics. Our units, we have the same unit, the numerator and denominator, the units cancel out. So then we end up with 2 pi over 3. Now, you can do the same thing if you don't like simplifying by hand. You could simply put in, we could ignore the pi because we know the pi is going to end up as part of the answer. You could put into your calculator 120 over 180, hit enter, and I believe that it will just simplify it, especially if you use those scientific calculators. It'll just go ahead and simplify that to 2/3, and then you bring the pi alongside. Okay, so when we're looking at negative 225 pi, we do the same thing. We're going to multiply by pi over 180 degrees, noting that the degrees, the units, which are degrees, cancel out. And how can you remember which one to use? I know sometimes we use 180 over pi, sometimes we use pi over 180. You look at your unit, you look at your degree, and you know you want to get rid of it, because radians, which they're asking us to write this in, radians do not have degrees, so we've got to get rid of that degree. So if the 180 degree goes in the bottom, it makes sense that then the pi would go in the numerator. All right, so we could do the same thing. We could put 225 over 180 in our calculator, and we could simplify, and we would get negative 5 pi over 4. Well, we'd get negative 5 over 4 in our calculator, and pi comes along for the ride because we have to multiply negative 5 times pi. I guess to get that, what would we have to divide by? I did this by hand. I divided it twice. I think I divided it by, let's see, I must have divided by 5 first, and that didn't simplify enough, so then I divided it by 9. So I guess dividing by 45 would work. Okay, yep, if we would have thought of that, dividing by 45. But no matter what your method is, this is the answer. These two, oops, yep, we got the negative. These two are the same answers. They represent the same angle, just like 2 pi over 3 and 120 degrees represent the same angle. They're just in different forms. All right, so now they're giving us radians, and they're asking us to measure it in degrees. So if I want degrees, that means I'm going to be multiplying by 180 degrees on the top and pi on the bottom, because then my pi's will cancel out, and I'll be left with degrees. So 5 times 180, that's going to be 900, so 900 degrees. So once again, 900 degrees, that represents the same angle as 5 pi. And over here, we're going to do the same thing. We recognize that we want degrees, and we have radians, so we're going to put the pi on the bottom. The pi's will cancel out. We're putting the degrees on the top, so we'll end up with degrees. We can do our, however you want to do this. I would do what? 6 goes into 6 once. 6 goes into 180 30 times, so we're going to end up with 150 degrees. So 150 degrees is the same thing as 5 pi over 6. All right, this is fun. We get to go back in time doing that. And yes, we're back to graphing. I'll tell you what, I do believe that you're going to be able to use your graphing calculator on your final, but at the same time, your graphing calculator is not going to give you the tick marks. It's not going to be as clear as if you did it by hand. It might be actually difficult to find the answer to this question on the final by just using your graphing calculator. You're going to have to know a little bit more, so let's go ahead and review it. So finding the amplitude, of course, the amplitude is the number right here. It's the absolute value of the number right there. So the amplitude, since the number right there is -1, the amplitude is 1. That doesn't change. And then we see that the period, we're going to remind ourselves of how to find the period. What we're going to do is the period is always 2 pi divided by the number in front of the x. So 2 pi divided by 4 is pi over 2. Yes, there's another way to find the period, and we'll talk about that in just a second. Because there's nothing that comes after the 4x, we know that there's no horizontal shift. I think they call this also a phase shift, but there's none. And then we think about the vertical shift. There is none for this too. So what do we do to graph? We're going to go ahead and we set the whole angle. The angle is 4x. We want to see where our starting point is, so we set it equal to 0 and solve for x. So we get x equals 0, which is our starting point. And we also want to know where our end point is for the first period, or one period. So we're going to go ahead and set that equal to 2 pi. We'll divide by 4. Is this coming back to you? I hope so. So x equals, if we reduce that, pi over 2. And that was the second way that we found our period. We took the second where the graph ended for one phase or for one period, and we subtracted where it began. And so that also gives us our period. All right, so let's have fun. Let's do some tick marks. Let's get this going. This is a lot of fun. Actually, you know I am having fun. Okay, our first tick mark is at 0, where we start. You know what, let me go ahead and, well, I can still use black, we'll be okay. And our last tick mark for one complete period is pi over 2. So now we need to find the middle. We're going to add 0 plus pi over 2. You know what, I'm going to write that down because some of you are going to need to see that. So we'll write 0 plus pi over 2. Okay, is equal to pi over 2. And then remember what we do with that number. Let me shift everything over a bit. Let's see. Okay, ooh, that's a lot of green dots there. All right, we'll just rather shift that a little bit. Okay, let's shift this whole thing. All right, so remember how to find the midpoint of something. You add the two endpoints, and then you divide by 2. And we discovered that if you can go ahead and, instead of dividing by 2, if you can multiply by 1/2, which is the same thing, it gives us an easier way to find the midpoints. And the midpoint's going to be pi over 4. And then, of course, we need to find the midpoint between 0 and pi over 4. So we'd add the two together. 0 plus pi over 4 gives us pi over 4. And to find the midpoint, we divide by 2. But the easier way to think about that is to multiply by 1/2. And so we get pi over 8. Because, of course, when we multiply fractions, we multiply the numerator times the numerator and the denominator times the denominator. So our second tick mark is pi over 8. And then we're going to find our third tick mark. We're going to go ahead and add pi over 4 plus pi over 2. Okay, not as pretty, because I'm going to have to find a common denominator. So I have pi over 4. And instead of pi over 2, I'm going to write that as 2 pi over 4. And when I add those together, I get 3 pi over 4, and I'm running out of room. So instead of dividing by 1/2, I'm going to multiply by 1/2. And this gives me what? 3 pi over 8, which is our third tick mark. Woo! Okay, so those are our tick marks. So on the final, you would be looking for a graph that had these 4 tick marks on it. And then we're almost done. We're going to go ahead and, let's see, what color should I pick? Let's do it blue. We're going to make our little table. We realize that we are looking at a sine function, and so we know that sine starts with 0 because sine and 0. And then the pattern is 0, 1, 0, -1, 0. Okay, I'm just running out of room. And we notice that the way we have it set up, once again, I'm doing it the shortcut. Feel free to find that first point by plugging in 0. You can plug in 0. You can say 4 times 0 is 0. And then sine of 0 is also 0. And 0 times a -1 is still 0. You can do it the long way. I'm doing it the shortcut that says if this is my pattern, the only thing I'm doing to my pattern represents this function here, and the only thing left that I'm doing to it is multiplying by -1. So with each one of these, I'm multiplying by -1. Once again, you don't have to do the shortcut. Okay, so we're getting our new points. And what we're going to graph, let's see. We need a 1 and a -1. And so let's see, our first point's at 0, our second point's at -1, third point 0, fourth point 1, and last point is 0. And so this makes sense. This looks like sine, except for it's upside down because it was reflected over the, it was not reflected, but flipped over the, reflected. We can say reflected because it was, right? But so flipped and reflected, whichever way you want to look at it, over the x-axis. And so that matches this equation. It's been a while, hasn't it? This is back in chapter 4, which does seem like a long time ago. All right, so let's look at this. I want you to note that on your paper and on my smartboard, it says y equals 5 cosine x minus 3. Okay, that's going to be really ugly to graph. Our tick marks are going to be amazingly difficult. So what we're going to do is see that 3, we're going to get rid of it, and we're going to make it into a pi. All right, so please, I'm going to do that with the color so it's really obvious that I'm changing it. Hopefully you're paying attention and you're listening to me so that you know why all of a sudden I'm covering over this 3 with a pi. It's like, oh, don't want to see that 3 anymore. I'm almost there. Okay. Now it doesn't look like a pi, does it? All right, but you know that it is a pi. Okay, I'm going to check on my time real quickly. All right, so here we go. There's lots of things that they want to know from us. They want to know our amplitude. So our amplitude is our 5 right there. They want to know our period. We know that the period is 2 pi divided by the number there. So 2 pi divided by 1 is 2 pi. They also want to know our phase shift, which is our horizontal shift. We know that pi is our horizontal shift because whatever comes after this x, or it could be a 4x, it could be a 3x, whatever it is, whatever comes after it, that's our horizontal shift. And because it's a minus, that means we're going to move to the right. It's always the opposite when you're dealing with a horizontal shift. And then we see our vertical shift here is a +1. So that's going to be a 1. That's going to move the whole thing up 1. So here we go. Let's have some fun. When we graph, what do? We set our angle right here, our x minus pi. We set that equal to 0 because that's where we're going to start. And we want to know where we're going to end one period. So we ended at 2 pi. So we're going to go ahead and solve for x on both. So we'll get that our new graph, our translated graph, is going to start at pi. So I'm going to just pick a random tick mark and say that's pi. Oh, that was not a straight line, but I'm not going to go back. All right, and we're going to end at 3 pi. It's obvious if you start at pi and you end at 3 pi that your period is going to be 2 pi. So it's always nice to double check and make sure we've got everything right. All right, we need to find a midpoint, and that's pretty easy, right? Pi and 3 pi, what's in between them exactly? A 2 pi. We could have added pi plus 3 pi is 4 pi, divided by 2 is 2 pi. What's between pi and 2 pi? I'll stop and do this real quickly because some people do like to see the work. So if I'm going to find the midpoint, I'm going to take pi plus 2 pi, which is 3 pi, and then I'm going to divide it by 2 this time because we're not dealing with fractions. Dividing it by 2 makes sense. And there we go. we've got 3 pi over 2. And then if we want to know the midpoint between 2 pi and 3 pi, well, that's 5 pi divided by 2. Okay, we've got our 5 tick marks. Your graphing calculator did not give you your 5 tick marks, did it? All right, so we still have to have our brains to use on the final. So here we go. After I get my tick marks, I stop and I make my shortcut. Let's see, what color should I use? I'll just use black. I make my shortcut table that basically says, look, I know I'm dealing with cosine, and cosine's pattern is a 1, then a 0, then a -1, then a 0, then a 1. Now, don't stop me. No, I'm sorry, don't stop me. You can't stop me because I can't hear you. I don't want to stop you from doing it the long way. If you really want to take the pi and plug it in for x, you can go ahead. It's really not going to take that long. I could plug a pi in for x, so I get pi minus pi is 0, cosine of 0 is 1, 5 times 1 is 5, 5 plus 1 is 6, okay? You can do that, and you can get that, we're going to take that, we're going to end up with a 6. We already just said we're going to end up with a 6. So how did we get there? Well, this 1 stands for what we got right here. So what are we going to do to it? We're going to multiply it by 5, and we're going to add a 1. And sure enough, that's going to be a 6. Either way, long way, short way, you'll have time on the final to do it either way. So I'm going to take my 0 times 5 plus 1. That's going to give me a 1. My -1 times 5 plus 1. That's going to give me a -4. And my 0 times 5 plus 1 is going to give me a 1. And my 1 times 5 minus 1 is going to give me, I'm sorry, plus 1 is going to give me my 6. So I look at my graph, and I know I'm going to need, this is not drawn to scale, absolutely not. So I'm looking at, I need a 6, so 1, 2, 3, 4, 5, 6. I need a 6, I need a 1, and I need a -4. 1, 2, 3, 4, there's a -4. And here I go, I'm going to graph when x is pi, y is 6. Let's see, what color should I use? I'm going to use blue. So when x is pi, y is 6, so our points up there. When x is 3 pi over 2, y is 1. When x is 2 pi, y is going to be -4. And when x is 5 pi over 2, y is 1. And when x is 3 pi, y is 6. So here we go. Okay, that looks good. Okay, solving equations. So this was chapter 5, and you know, it's never a bad time to review solving equations. So we're in an interval from 0 to 2 pi, so that's good. So what we're going to do is divide both sides by -4 and clean it up, and we'll say cosine of x is equal to -1/2. And yes, we're going to have to think about the unit circle, or you could just do inverse cosine of -1/2 on your calculator. Either way for the final is fine. You know, my love for the unit circle never ends, so I'm going to use the unit circle. Okay, so where's cosine equal to -1/2? Well, we know cosine's equal to +1/2 at pi over 3. So negative, cosine's negative in the second and third quadrant. So at 2 pi over 3 and at 4 pi over 3. These are my two answers, and I'll write them. X equals 2 pi over 3 and 4 pi over 3. Am I done? Yes, because I am stuck in this interval 0 to 2 pi, and there are no other answers for x within that interval. Okay, this next one, we noticed that we have a 3x. And remember when I taught this and I said, we're going to apply something that we use in life a lot, and that is denial. Okay, we're going to deny that there's any problem here. No, that's not really a 3x, we're going to say to ourselves. And we're just going to go ahead and solve it like as if there was an x. So where is cosine equal to -1? Well, we look at cosine. When cosine's -1, that's when theta, or the angle, is pi, right? So we're going to have, we're going to say 3x is equal to pi. Now, if it were x, we'd be going about this a little differently. But we're going to stop and say, well, you know, there really actually is a problem. We need to just address it, and everything's going to be okay. We're just going to work on it. All right, it's not that bad. So we want to solve for x, and what are we going to do? We're going to divide both sides by 3, and we're going to say x is pi over 3. Okay, now I want you to stop and recognize this problem is a tricky one. So if you see anything like this on your final, whether it be on your multiple choice or your free response, I want you to stop and think. Yes, we're in an interval, but do we really think that's the only answer that's going to fall in this interval? Because pi over 3 is awfully small. Let's see if we can get another answer. So let's go back to the 3x equals pi. Yes, you're right that at pi, cosines equal to -1, right, and sine 0. But how about if I went around, you know, let's see, I'm going around, there's pi. Oh, if I went all the way around again, that would be 3 pi. Would that work? I recognize that 3 pi is bigger than 2 pi, but remember, we're not dealing with x. So another possibility would be we could have 3x equal to 3 pi. I hope you're catching on here, because look what happens. Even though 3 pi can't be my answer, well, I'm not done with my answer anyways. I have to divide both sides by 3 to get my answer. And x equals pi, which is another answer, does fall between 0 and 2 pi. Do you think there are any more? Let's check. So let's see. We already said at pi, cosines equal to -1. At 3 pi, cosines equal to -1. Let's go around one more time and look at 5 pi. Okay? Because cosine at 5 pi is also equal to -1. So now, for the third time, we're going to set 3x equal to another variation of where, another angle where cosine is equal to -1. And yes, you're right, 5 pi does not fall in this interval. But when we solve for x, 5 pi over 3 does fall within the interval of 0 to 2 pi. Just barely, right? Because 6 pi over 3 is going to be 2 pi. So when they say solve the equation, they're saying solve for x. And x can be equal to anything between 0 and 2 pi. And so we'd have 3 answers. If this were multiple choice, we would have these 3 answers to look for. And if this was fill in the blank, not fill in the blank, but free response, we'd have to write all 3 of these answers to get this right. So if you have any questions about this, feel free to ask. Well, if you're watching it in 2016, you'll know that I'm not here to ask. So feel free to ask a colleague, a peer. I guess you guys are colleagues. Your job is one of students. So ask a colleague, a peer. You can even, I believe our sub knows calculus. You can ask the sub. You're welcome to ask Ms. Parks or Ms. McCahan. And if you don't get an answer, you can always ask me right before the final when I come back. Come find me actually on Monday. Once again, if this is not 2016, this doesn't make any sense for you. But if this is 2016, find me on Monday, the last lab, which is only an hour right before 5th block final. Okay, and I'll explain this one to you. All right, write the a sine function equation from the info below. Assume that a is greater than 0. Okay, so a, that would be what? The number that's in front of our, that would be our amplitude. So we're assuming that we have a positive amplitude. That's what we're assuming. All right, so let's look at this. If I've got the amplitude of 1/2, I know that my amplitude goes in front of my sine function. So I have 1/2 sine, and then I got to stop and wait to see what kind of angle I have. This tells me my period is equal to 2. Okay, let's stop and think, how do we get our period? Well, for a trig function, how we get our period is we take 2 pi and we divide it by the number that's in front of our x that follows our sine function. So we go ahead and say, all right, well, apparently it looks like to get the 2, we took 2 pi and we divided it by whatever that number is. Remember, we always used a box because we didn't really get attached to the A, B's, and C's and all that stuff with the formal formula. And so we realized we're going to set up a proportion. So we cross multiply. 2 times a box is 2 box. 1 times 2 pi is 2 pi. And then to solve for the box, we're going to divide both sides by 2. Is this coming back to you? Is this something your graphing calculator can do? I think not. So now we know that the box is pi. So I'm going to put pi in the box. I'm also going to make x be green. All right, so far so good. And then we see vertical shift, we have none, so we're not going up or down at all. But the horizontal shift, it says right pi. You know what that means? The right part means that a minus is going to follow the pi x, and then pi. Okay, I know that looks very, very strange. Let's go ahead and get rid of the box like that. Okay. If you don't like the way that looks like, or let's say this is a multiple choice question on the final, you would want to probably pull out the pi, factor out the pi. So we could rewrite this whole thing like this. We could factor out the pi, and what would be left? We'd have x minus 1, and that might look a little bit more reasonable. Okay, with this next one, once again, we have to assume that the amplitude is positive because when they give us the information, amplitude is positive. So what I'm saying is, sometimes we could have y equals -2 sine x, and this function would also have an amplitude equal to 2, but there's a negative in front of it, which would allow it to reflect over the x-axis. So we are assuming that that number in front of sine is positive. So we can start this out, and we can say that y is equal to 2 sine, because they're telling us we have a sine function. They're telling us that our period is pi over 4, and we're like, where did the period come from? So we're going to remind ourselves that we get the period by taking 2 pi over the box, and so the box is what happens in front of the x. It's what happens right after the sine and right before the angle x. And so we're like, okay, so if the period is pi over 4, and we get the period by by taking 2 pi dividing by the box, then we're going to cross multiply. So we'll get what? 2 pi times 4 is 8 pi. Pi times the box is pi over, pi box. We're going to divide both sides by pi. And we're going to get that the box, what we put into the box is 8. I hope this makes sense, because basically what we're doing is we're saying, hey, if we want our period to equal pi over 4, then we better put something in the box that when we divide 2 pi by it, we're going to get pi over 4. 8's your man or your woman, right? 2 pi divided by 8 is going to give me pi over 4. All right, so vertical shift up 7, horizontal shift none. Okay, so with the horizontal shift being none, that means I'm not putting anything, after the sine. I'm not putting anything after the angle. So let me undo that and undo that little scribble. Okay, but I do notice that my vertical shift is up 7. A lot of you like to put that here. I personally like to write it like here, like that. So depending on whether this is multiple choice, if you see something like this, or whether it is free response, you're just going to, that's what is going to cause you to either write it or choose the answer like this, or to write it like that. Either way, both of them are the same thing. Oops, I didn't mean to box out the 7. 7, you are included. All right, so I'm getting a little punchy here. It is 4:45. I've been doing a lot of tutorials to cover my 6 days of absence. So, and no, people that are maybe watching this in 2017. I am not going on vacation. I am traveling to Miami because my parents were in a car accident, but good news, they are really doing a great job recovering. They're both 85, and yes, that's old, but hey, they used to work out 3 days a week at the gym, and I think they'll get back there too. All right, so last two problems, 13, find the exact value of cosine pi over 6 plus pi over 4. I feel like this is, well, this is the backwards of the first two problems that we did in this tutorial, so let's look at it. I know that this matches with the cosine formula that says cosine pi over 6, cosine pi over 4 minus sine pi over 6 sine pi over 4. Yes? Yes. All right, let's have some fun. You can use your calculator. I'm going to think about the unit circle. I know that cosine of pi over 6 is root 3 over 2, and cosine of pi over 4 is root 2 over 2. Oh, bad news, right? Because the answer is going to require us to know the unit circle, because there won't be, if this is a multiple choice question, there's not going to be the decimal approximation answer, though I'm sure if you're clever, you'll figure out a way around that. I'm not going to expand on that idea. All right, so here we go. Sine of pi over 6 is 1/2. Sine of pi over 4 is root 2 over 2. We're going to multiply root 3 times root 2 is root 6. 2 times 2 is 4. One of the most profound problems we've done, right? 2 times 2 is 4. I'm really getting slap happy here. 1 times root 2 is root 2, and 2 times 2 is 4. We're almost done. Let's put this together. Root 6 minus root 2. No, we can't combine those. They're not like terms. There you go. And our very last problem, drum roll please. Let's see what our time is. Okay, 37 minutes. Let's see if we can get this done in 40 minutes. All right, in which quadrant is sine greater than 0 and secant less than 0? So when we think of greater than 0, we're really saying where is sine positive? Sine is positive in the first quadrant and in the second quadrant. And then when we're talking about where is secant positive, we have to remind ourselves who secant is. Secant is 1 over cosine theta. So what we're really looking for is where is cosine positive. Cosine and secant are positive in the first quadrant. And let's see, cosine and secant are positive in the first quadrant and in the fourth quadrant. Sorry, I'm looking at my paper going, what did I write? Because that's not what I wrote. So let's see, where are sine and cosine and, sorry guys. Yes, you're like, Miss Overby, stop. We don't care where they're positive, and that's why it doesn't match up with what's on my paper. We want to find where cosine and where secant is less than 0, so where it's negative. All right, thank goodness I didn't end on a bad note. Almost did, caught myself. All right, cosine and secant are negative in the second quadrant and in the third quadrant. So where are they both? Where is sine positive and secant negative? Second quadrant. That's going to be our answer. Let's just double check that. Yes, sine is positive in the first and second quadrant. Cosine is negative in the second and third quadrant, so secant is also negative in the second and third quadrant. Woo! We're done. Please have fun completing your 3 final review packets. If you do that and you really spend time trying to remember and review and understand all the trig we did this semester, you're going to do great on your final. So have a good time studying and completing the packets, and I'll see you in class. Thanks.